of the rope swing. So the purpose of this lab is to investigate the motion of a mass system swinging in an arc attached to the rope. I used a wired mouse, so the system will be the mouse and the rope, which is the wire, and surrounding will be the earth. So the brief preview of the results is that considering air resistance, the system's total energy declines, and the predicted and observed models are similar to the actual, and the experiment demonstrated the energy principle. So fundamental principle that we have to know is Newton's second law, which is a system's change in momentum is proportional to the net force applied. And we will consider as a net force the gravitational force and centripetal force caused by the tension. And the energy principle, which is the change in energy of a system equals to work by surrounding on system plus exchange of thermal energy. But we will not consider thermal energy in this lab. So this is the observed motion. Sorry for the lagging. So if I do the tracker analysis, we can know that in the x direction it has more period, which is not appropriate term because this is not a spring mass motion, but still the y has more of a short period in this case. So if you see the initial condition and tension in the computational model, since the ball, which is the mouse, was started at rest, it was the initial vector is 0, 0, 0, 0, and the length of from my hand to the center of mass of the mouse was 105 centimeter, which is 1.05 meters. And I wrote a while loop considering force of gravity and divided by the force into parallel and centripetal force, and I considered tension into account. And also by setting B as a 0.05 here, I consider drag force, which is air resistance, and this is the result. We can see it is pretty accurate to the real motion since we account the air resistance. So possible errors. The first thing is because of wired mouse. I simply held the wire and swing mouse, and so that my hand might have blocked the path of the mouse. And second is point mass. Since the mouse has complex shape, the mass distribution is not even within the mouse. And third is hand tracking. Through manually setting the center of mass of the mouse for every frame, there might be a lot of deviation due to this. One further question that I come up with, what happens if I don't include the air resistance into account? And this is a result. Even though we can see the total energy still declines, but the overall rate of decrease significantly reduced. So it's almost it's not identical, it's not constant, but it's almost. So this model might be more appropriate for the simulation which consider ideal experiment situation. Thank you for watching this presentation and have a good day.